This video will explore and discuss the algebraic process of completing the square. Here's what you should already know before we get into it. This equation is called standard form. It's the main form that all quadratic equations are written in because it has an x to the power of 2. If you were to graph it on a coordinate plane, it would make a shape called a parabola, and this parabola could also be opening downward. If the value of a is greater than 0, meaning it's positive, then the parabola opens up. If a is less than 0, meaning it's negative, then the parabola opens down. Last thing you should know about it is c, the y-intercept. That means if x is 0, you get the y-intercept, which is where the parabola crosses the x-axis. Here's something else you should already know a little bit about before we get into this. This equation is called vertex form. On a coordinate plane, you would still get a parabola that could also be opening down. But more importantly, we have another vocab word called vertex. That's the maximum or minimum point on the parabola, the highest or lowest value. Where is the vertex located? Well, that's easy. It's whatever the values of h and k are. They are the x and y values of the vertex. One last concept you need to know is called the axis of symmetry. It's the imaginary line that splits a parabola in half. It always has an equation that says x equals h, which is the number on the x-axis that the symmetry line passes through. Okay, one last thing you need to know. You gotta know your perfect squares. They're these numbers right here. They're special because if you take their square roots, you'll get these numbers here. Notice how it's 1 through 12. A perfect square is a number that you get when you take any number, let's just say 13, and you multiply it by itself, which in this case would give you 169. And 169 is a perfect square, because if you take its square root, you'll get 13, which is why 169 is a perfect square. So why do we need to learn this process to begin with? Well, let's say I give you this quadratic equation and ask you the question, what is the y-intercept? Well, that's very easy to answer when you know standard form. The value of c is always the y-intercept, which in this case is 0, 3. Okay, let's say I give you this equation, which is in vertex form, and I ask you the question, what is the vertex? Well, that's also very easy to answer when you know vertex form. H and k are the x and y values of the vertex, which in this case are 3 and -4. Notice how you are taking the opposite of -3 in the parentheses, and you're writing down the answer as +3. So h is +3, k is +4. So, one last time, why do we need to learn this? Well, let's say I give you this quadratic equation, which is in standard form, but I ask you the question, what is the vertex? The problem is, the equation I'm giving you isn't in vertex form. There isn't an h and k value that we can see to get the vertex. How do we determine h and k from this standard form equation? Well, we know a is 1, b is -14, c is 46, but what are h and k? What are the vertex values? Well, completing the square is the process that converts standard form, which looks like this, into vertex form, which looks like this. So, what does the act of completing the square actually mean? Well, let's first understand the math that's going on behind it. This is a square. We know it's a square because all 4 sides are the same. You can find the area by multiplying the base and height, which in this case is 4 times 4, which is 16. In algebra, we learned that side lengths can be represented with variables or expressions, like these binomials could be the base and height of our square instead. Well, what would be the area in that case? We know the base is x plus 4, and we're going to multiply it by the height, which is also x plus 4. But here's some algebra for you. The same expression, x plus 4, is multiplying itself. That means you can take x plus 4 and raise it to the power of 2. Does that look familiar? Remember vertex form? The x minus h part is being raised to the power of 2. You think that's a coincidence? Definitely not. Now, when you multiply these binomials together using FOIL, you're going to get the following expression, which is called a perfect square trinomial. We know this because 16 is a perfect square. So again, what does completing the square mean? Well, if we had a rectangle which doesn't have equal sides, we could still find its area by taking the base times the height. You could still have expressions be the base and the height, and you could still multiply them together. And even then, you could still use FOIL to get the area. But this expression that you would get isn't a perfect square trinomial. 10 is not a perfect square like 16, 25, 36, 49, etc. We need a perfect square to get the x minus h to the second power part of vertex form that you see circled in green right there. We need that to find the vertex, which is the whole point of this video. If there were only a way to make this rectangle into a perfect square, which would allow us to get the x minus h part of vertex form. Fortunately, we do have a way. It's called completing the square. We are going to force these binomials, which are not the same, to become the same. And here's how we do that. How to complete the square. Well, here's the first example. Start by taking the c term, which is 46, and moving it to the other side. Leave a nice big space after the b term, like you see here. You're going to need that space later on. Now, for the most important step, take the b term, which was negative 14. Divide it by 2, which gives you negative 7. Then raise negative 7 to the second power, meaning you multiply it by itself. That gives you 49, which is a perfect square. Now add 49 to both sides of the equation. This is basically the part where you have now forced the rectangle into a perfect square with side lengths of x plus 7. How do I know it's x plus 7? Well, you just take the square root of 49, which is again a perfect square number. You need to set up parentheses with an exponent of 2. Every single time, this is what you do after you take the square root. Then bring the x and the square root of 49 down, which is 7. The symbol in between them is a negative sign because there is a negative sign in front of the b term. Now just combine like terms on the right side and you're basically done. You get 3. Now here's an important side note. This current state of the problem is called PQ form. It's basically the part where you identify the important numbers you just got from completing the square. P in this case is 7. Even though it says negative 7 in the parentheses, you take it as its opposite, which is positive 7. Q in this case is 3. Now we're almost done. We need to get our PQ form equation into vertex form. To do that, just move the q value, which was 3, to the other side. Once you do that, you're done. The 0 can be replaced with a y. So now we can ask ourselves, what is the vertex? Wasn't that the entire point of this? Well, yeah. Remember, the vertex is h and k. H is inside the parentheses, and k is the number being added or subtracted. The vertex is always h, k. And in this case, h was 7, the opposite of negative 7 in the parentheses, and k was negative 3. We also know the minimum height was negative 3, which is always the k value, and the axis of symmetry was x equals 7, the h value. And that's everything. That's it. So now let's do it again. Here's the second example. And here's a summary of the steps I just did to get example 1. You should maybe pause and repeat those steps as need be, write them down, whatever. Here we go. Step 1 was to take the c term and move it to the other side. Remember to leave a nice big space after the b term. Now for step 2, the most important step. Take the b term, which was negative 12. Cut it in half, which gives you negative 6. And then square negative 6. Raise it to the power of 2. That gives you 36, which is none other than a perfect square. Again, I just took the middle term, cut it in half, and then squared that answer. Add your 36 perfect square to both sides. This is the part where we have now forced the rectangle to be a square again. Now finish step 3 by taking the square roots and combining like terms. Always set up parentheses with an exponent of 2, and you can go ahead and put an x into those parentheses first. Then write down the square root of 36, which is 6. You get the middle symbol by taking whatever the symbol was for the b term, and then combining like terms gives you 25 for the q value. Because again, we have to acknowledge the PQ form and the important numbers that we just got. P is 6 and Q is 25. Remember, P is always the opposite value from what you see inside of the parentheses. Lastly, step 4. To get this into vertex form, just move the Q value to the other side. This is what we'll get, and we now know the vertex is 6 and negative 25. Remember to take the opposite of the negative 6, since it's inside the parentheses. We know the minimum height is negative 25, and the axis of symmetry is positive 6. Okay, one more example that has a little bit of a twist to it. You still start off step 1 the same way. You move the C term to the other side, and you still leave that space after the B term, but you always need to factor out a GCF if it's there. The x squared term has to have a coefficient of 1 in order to do completing the square. You have to divide out a factor of 2, just like this. Leave an open parentheses and divide by 2. 2 divided by 2 is 1, so we have just 1x squared, and 8 divided by 2 is 4. Still leave that space inside the parentheses and bring down that negative 6. Step 2 is still the most important step. Take half the b term, which was negative 4, so half of that makes negative 2, and then take negative 2 and raise it to the second power. That will give you 4. Add that 4 inside the parentheses. But here's the catch. You have to add 8 to the other side because there is a GCF of 2 in front of the parentheses. You have to multiply that 4 by the GCF of 2, which gives you 8, and you add 8 to the other side. I know it's a little confusing, but practice makes permanent here, so let's keep going. You're almost done. Just take the square roots and combine the like terms. Bring down that 2 on the outside of the parentheses as well as the x. Set up the other parentheses with that exponent of 2 on it. Put a minus sign because that's what was in the middle of the original equation. And then negative 6 plus 8 is 2. You now know the P and Q values. And after moving the Q value to the other side, you have vertex form right there in black. The vertex is 2, negative 2. The minimum height is negative 2, and the axis of symmetry is also going to be 2. All right, here's some practice that is no harder than what was just shown. You should pause the video and try to work these out. Hit resume when you're ready. The answers with work shown will appear, but I've rambled enough, so I won't be explaining these ones. Reach out if you need any help in understanding them, and replay this video for more practice. And thanks for watching. All right, go ahead and hit pause. And that's a wrap. Thanks for watching. I hope this video helped you guys out, and I'll see you next time. Bye-bye.